Hello everyone, I'm Xiao Gang. Okay, in this lesson, we'll start writing the framework for our async node. Alright? Okay, so in the previous lesson, it seems we placed the ik character in the wrong position. Let's swap it. The character was written in the wrong position. It should be written here. Okay, this part here should be written in this CP. It was probably copied incorrectly in the previous lesson. Okay, let's go back and put the external declaration of this character here. Then we'll write this async blueprint node. We've written this node many times. I'll just copy it over one by one. And as we copy, I'll explain to you what this is. First, we definitely need to include the 3 header files for HTTP. We'll put them here. We need to make sure our build.cs has already added them. That's fine. Then at this point, we definitely need to include its rect type and RSP type, right? Let's hide this provider. We just need to look at the public part. So let's include it. Okay, alright. As for this type, we haven't written it yet. But actually, this type is the request data sent when we make a request. So what is this RSP type? This RSP type is the response data sent back in the reply. Everyone should be familiar with this concept. Then, next is our reflection file. This reflection file, it is actually our file name, plus our density file. It definitely won't compile here because we haven't written UCast yet, so it won't compile. Then we need to declare a dynamic multicast. This multicast, I'll put the archaeology and then explain it to everyone again. Okay, we'll break down each line for everyone so you all know what we're talking about. Okay, this multiwave is our execution pin. How to write a blueprint node in one step. It uses this execution pin. And as for its delegate, we call it xg. Simple. Then xf silent. Elegant. And it has 4 parameters. The first parameter is our unique ID. Then the second parameter is this result. The third parameter is information. And here there is a returned struct data and the name of this data. We don't have this struct yet. Let's see what we call it. Let's just leave this name here for now. Let's place it at this position. Now we need to declare this struct. Because only after this struct is declared can this delegate compile successfully. Then we go to our RSP location. Let's place it. First of all, it is definitely a struct. This struct should be placed at the very bottom because it also needs to involve some other data. This struct definitely needs to export macros. For exporting macros, here, it is this one. Then we copy it. And here it should be API. Its name is the name declared here. That is its struct. With the struct in place, we definitely need a struct body. For now, let's not write the parameters inside it. Let's write another intern32. A equals a simple placeholder. Then we fill in the reflection file here. Because it is a uStruct, this should be here. Good. Okay, so then this return information is defined. And here, it still won't compile here because it actually still doesn't have the reflection file. We need to finish writing a UClass. Then it will compile successfully. So let's start writing our UClass free. First, the metadata tags for our UType file. Then it must be a class. Then let's try to block this red error. Try it. Next, we need to write the name of this class. It is first of all a UClass, so it starts with U. We make it publicly inherit this class from our engine. That's not it. Then let's try this engine class. It should be in... Let's check. It should be written in time. It should be this one. We mainly take this piece of code. Here we directly try it. This one. Okay, after relying on it, we can actually include the header file. But okay, we won't do it now. Let's still include the header file. At the very top, it is this header file. Inside case mean, there is this header file. Okay, then after including it, we add this part here. Okay, so Now we add the body of its class to okay. Then here we set it to public and also write the constructor and destructor for it. After writing that, we then create its implementation. Okay. Alright, at this point we should be able to compile successfully. Let's compile it. Make sure it compiles successfully here. If you write a lot of code later and then compile, it's easy to not find where the error is. Actually, okay, once this is passed, we start writing our method, still following our standard Xiaogang style routine to write it. First, you need to write a method that our blueprint can call, right? So I'll copy this method over, okay. Change the name. This method has several parameters. Here we have these three. This one is definitely the world context object, nothing special. And these three things are our key information, nothing special either. Then here, he needs to confirm what type of image it actually, like either JPG or PNG or BMP. So here we also need to prepare an enum. Then this theorizes data, and it needs to return this ULF disappointer. It will do further work later. Right? Let's take a look. Then we need to change the display lamp here. I'll change it to X simple. Change this to Shunfei. Then for keywords, there's no problem using this here either. And then the simple here. Then we'll take this and divide it into several more parts. Okay. Because we might need to do other things later. Then we need a rectangle here to see what type of image it is. So we'll define this rectangle in this position. Define it in our required type. Then we'll move it over here, and then after this rectangle's side needs a rectangle, because this rectangle is again this kind of rectangle that needs to be reflected into Blueprint. So we add the reflection file to it like this. Okay, then for this enum, let's change the name. Okay, so we didn't write anything for this enum, like long or max, just to save some trouble. Normally you should write it, okay? So we remove this part and just write directly. In app, in API secret, in API key. The reason for writing it this way is mainly for convenience when copying. Because with too many prefixes, it becomes inconvenient when we paste it later. So here we handle the comment simply. Okay, now that we have this node, let's create its implementation. This way, the blueprint can remove this node. But this node currently doesn't have an execution pin. It hasn't been defined how to activate it yet. So, on our side, we'll write our routine online. Okay, this part is 2. This side doesn't need this override, because only this activity has an override. Okay, after these two methods are done, then we'll proceed to write other methods. First, we definitely have a method for sending HTTP. As for this sending method, it mainly just needs to specify the URL and the content. There's nothing else. Then after HTTP sends, there must be a receiving method. Then when we succeed or fail, we certainly also have a corresponding method. These 4 parameters actually correspond to these 4 parameters here. Then we change it to spy info. After this is done, we definitely have a release of resources. Because there is binary data here, it is actually still in memory. Okay. Then after this is done, we start to supplement our execution pins. As for these execution pins, actually, they are mainly these 3 execution pins. 3 execution pins. These execution pins should be this one. Then the execution pins. Oh, we need 3 to execute that white triangle. Then next, we need to take the data we want to hold in the middle. Let's record it. Because this needs to be executed in one step, so we must find a place to store this intermediate data. As for our image type, we'll give it a default image type of JPG. It's just a default option. And here we prepare a TLV uint8 because when we generate this data, we need to put it here. That is, we need to hold it for a few frames. Then when we receive it, it's the first frame, and when we send the data, it might be the second or third frame. Then actually we need to decide on this side as well. These needs are require info. The meaning of this require info is actually quite simple. It is mainly used for our requests. We have an interface that needs to be encapsulated. We are not writing this interface now. We put it here. Then we just copy this part the same way. Then this struct does not need to have this export read. Yes, because we don't need it. We don't need to let the user construct this. This thing is for internal use. Then change this name here. But we still need to make it support this reflection. Yes. Okay, let's go back. Let's go back here. Okay, so at this point we have basically defined our framework. And then I'll write another method here. This method actually, its logic is actually quite simple. It's to convert this image type into something based on the image type. But we're not using it now. We won't write it for now. Okay. So let's implement each of these methods. Since we've actually already walked through this framework together, we didn't go into detail about these frameworks again, and didn't create each method one by one, following the process. So here, let's first take these two things, success and failure, and complete them in this one frame callback manner. Obviously, this is still the delegate. This delegate. Okay, so here is success. Execute. Okay. So obviously this is a failure here. For copying here, copy the failure delegate. Just the failure one is fine. Let's check the failure pin. It should be this one. Oh. Good. Okay. So after the success and failure, execution is complete. There's no problem. Then we can directly write the realize, because we already have the data. First clear all 3 pins. Then set the IDs of our 3 apps to empty strings. But you don't have to set them to empty strings. It can be automatically reclaimed. But I'm used to it on my end. I need to set it to this empty value. This is the data on this side. It's equivalent to reclaiming resources. Then also clear this custom data. And at the same time clear the preview info as well. Okay. At this point, the most important thing is actually to tell the engine that this UClass of ours can be reclaimed. Then there shouldn't be any issues. As for this reclamation, actually here one is only called the destructor function. We need to call it to ensure this thing is reclaimed. And the most important part is still in our HTTP. The last step of the response, we also need to call it, but we still have a chain of judgments before that. Let's set up this framework first, okay? Then let's write our activity now. Activity is just for cross-increment forwarding, so we shouldn't actually write this code. And here, first prepare a respire info. The respire info here should be this one, okay? Okay, after writing this FISB info, we need to broadcast it. We broadcast at any angle, and we also inserted a GUID here. So let's write this GUID here as well. Our custom ID. At this point, we can't leave it empty. We set it to a 6. Okay, then when we release it here, we also clear it out. Okay, so after clearing it here, we are still here. Here we send this thing out. At the beginning, it doesn't have a result yet. You need to wait a moment. This is to avoid some people connecting the pins incorrectly, and then asking you Why this node didn't execute? Actually, it did execute, but you didn't get the real result. Okay, so now we will cover that in the next lesson. This lesson mainly focuses on completing the entire framework of this Blueprint one-way node. We have finished the whole framework. Then in the next lesson, we will start to get into the commercialized process of training and fly. Such a commercialized process of encapsulating data, then signing the interface verification, and then obtaining the data. It also includes some image encryption processing and parsing and generating some JSON. Alright, we will stop here for this lesson.